Okay, let's go. I'm gonna do. The two options are 4.5 hours of the learning and then an hour and a half of testing, so 6 total. But I have to do the test at the fucking house where I'm watching dogs, which is annoying. I'm doing more than normal this week, anyways, study wise, so I'll just do what I did yesterday 2 hour-and-a-half sessions of study and then an hour-and-a-half test. Okay, let's go. Whatever the fuck in and out parameters are. Like, what would that even be? Oh, let me turn the light on. I forgot. In and out parameters. So what, like parameters that I'm passing in but wanting to bring out? And the reason that they're parameters is because I can only return so much data. I can't return, like I could bring in a reference as a parameter and then return it as a reference, but what if I have to do multiple? Then I pass 2 references into a function. I fuck around with the references. I think I've done that before. Yeah. A perfect example is the sort to integers function yesterday, where I have integer x, integer y. I pass them into a function which has parameter references to receive the variable. So we're passing them via reference. I'm checking to make sure that the lesser one is actually less than it. If not, then we flip them. Otherwise, we say that they're equal, and it's void. But we're just updating the references, so you can do multiple things in a function, like maybe a sort function where I pass it a parameter that's some sort of list or array or something, and it's this long one, and then I have some sort of algorithm in the function that sorts it, and then it's void, so it doesn't return anything. Maybe at the very end it says if successful, blah blah blah. It says successful, or if it fails, whatever. Or if there's some sort of if there's some sort of failure when it's doing it, then whatever, it can say that. But then that's it. It just messed with the references. There's no return value. It's just that the parameters were changed. Okay. Okay. A function and its caller communicate via 2 mechanisms: parameters and return values. Because we pass. Well, I mean, I guess the arguments are what are used to initialize the parameters, but the point is that the parameters exist to receive the arguments, and then they return the whatever. Yep, value reference address, sure. Oh, meaning like when we actually need to change them. Yeah, it seems like I'm on the right track so far, where so far the best practice has been, hey, you want to get a value to the function? Your value is expensive? Or is it not expensive? Okay, just pass it by value. Okay, cool. Oh, you want to get the value there, but it is expensive? Or at least it would require an expensive process to get it there, by copying a standard string, or I don't know, a class or something else that's expensive. Oh, let's do const reference. That way we look at exactly where that value is in memory in its object, and we can just look at it. We can't change it because it's a const reference, and maybe it's a const object, but we can at least bring it in the function so we can look at it and do stuff, use it, but not change it. Or maybe we pass it by a reference that's not const, a non-const reference, to change it. Because we need to change multiple things, not just one. Okay? Maybe we have multiple, like we have we have 2 standard strings. One is previous target, one is current target. Both are 0 at first, but whenever we set the current target, let's see, how do we do this? If the current target is set, whenever we set it again, we set whatever the existing target is to be the previous target. That way we always know what the current target is and the last one. Well, maybe I need to update both of those in a function. It's update targets, and I pass it a reference to a non-const. Both of these are non-const, current target and previous target. And we need to update those references. So previous target now gets the value. It is now getting the value from current target, and then we update current target to be whatever. So maybe I pass 3 things. Hey, previous target, update it to be the current target. current target, update it to be whatever the new target actually is. And I mean, I could do that real quick. Let's get music going real fast. Is this any good? Probably. All right. Oh, I feel fucking locked in. I guess I got enough sleep or something. I feel really, really good right now. I kind of want to type just for a second. It's stupid and it's ego flex, but whatever. I just feel really locked in. I just kind of want to... Oh my god. I just needed to do that for a second. I just needed to type something. I don't know. I'm feeling mega energized. I don't know why. Like, it's like I'm locked in right now. All right. So we need standard string as well. Please just click in there. Why is it doing that? How would I actually want to do this? So I would just go include string, need standard string, and then oops. Excuse me, and then end it there. Okay, cool. And then we'll have sure. Previous target. Current target. And then how do I want to receive this? I want references there, but I want to pass in a literal here for the third. But how do I want to receive it? Can I do... Is it cheap to initialize a standard string with this? I can't remember. It's probably fine. We'll do goblin, sure. Oops. Standard string reference, prev target, standard string reference, current target, and... Oh, I could do a standard string view to view it because I think it's cheap anyways. Oh wait, we're in the function, not there. Okay. Oops. Instead of a reference, okay. Let me blow my nose real quick. Allergies are really, really bad today. Oh. There's a loose piece of thread right here. One in my nose. Okay, please. So we want to save the current target as the previous target now. And then current target, oops, is now new target. And then, is that it? Cool. Okay. could just do that too. Nah, I need... sure. I guess I'll do this. That's fine. I was using the wrong value, wrong thing anyway. Oh, it needs... consts because we're not changing it via this. I mean, I guess I could do that, but I'd rather... how would I want this? Like, I could do this and then have it be one line. But, I don't know, I think it's more readable this way. Let's check out. Let's check. Validate my assumptions, always. I could do that too, or I could just do... previous target, current target, yeah, sure, let's do it this way. Nah, I don't like it. It's one more line, but I don't care. I think it enhances the readability. Excuse me. Oops. Ugh. Oops. First, we didn't have any targets. Oops, why is there a space there? Previously, no target. Not current, not previous. And then, well, let's see. Then I could just do that, or I could just make it so that if they're empty, we don't care. That's fine, whatever. Leave it as is, it's okay. Yep, target's updated, previous target. Alright, so targets at first, nothing. Okay. We could just say check targets, but either way. But then previous target, current target is now goblin. And then now the previous target is goblin because we've just selected orc. And then, oh, we get orc now. Now, oh, and then we get whatever. Dragon. No, it's orc and dragon and goblin is thrown off. Cool. Nice. I think that's the point here. We're going to be passing parameters in. That way we can update the values there instead of just looking at them. Before, we haven't really been changing them that much. I mean, sure, we've been showing, oh, hey, here's a pointer to something. Here's how we can dereference it to change the value that's at that location in memory. But, or at that object in memory, because we can't just do it wherever we want. There has to be an object there, apparently. Let me do a test. Asmongold. All right, let's go. Okay. Yeah, typically we pass by const reference or value because we're not changing the actual object we're passing. But sometimes we might want to. Maybe we want to do it for multiple. Maybe if it's just one, we just return it. Or maybe not. Oh, excuse me. Okay. Function parameters are usually only used to receive input from the caller. Yeah, that way we can do shit here. It's usually not changing stuff that exists in our memory. Receiving. So like, yeah, I guess those ones earlier were out parameters versus an in parameter that would be like, I don't know, print students in class, and I just pass it a number and it has an integer parameter. That's an in parameter. It's only used for bringing shit in, and it's odds are we probably return shit, or maybe it's void and we just look at it. In this case, it's void and we look at it. In this case, we just look at it. Print 5. Okay, we have overload, so we're gonna call int because it's an exact match. Boom. Okay. Yep. And then we have standard string that exists. We have to initialize it because there's no literal standard string unless we include something suffixes, and we suffix this with x or with s. Cool. Print s. Okay. Yeah, these are in parameters. Yeah, or a pointer to a non-const. I'll do the same thing. I'll make the same thing I did earlier, but with a pointer. Only difference is I replace the reference with a pointer. And we make sure that we aren't dereferencing null. So you check if it's valid first. Don't need it yet. Yes, I do. Reference versus standard string versus pointer. I think standard string is better. And when was standard string better? Just for viewing in general? I don't know. I think it's the same result either way, but I can test with the optimization later. It's same outcome. Oops. Standard string, a pointer to a standard string, and then it's prev target. Sure. Standard string pointer, current target. Sure. Oops. I'm getting faster at typing every day, so I'm at like, depends. It's somewhere between like 100 and 140, just depending on how easy this stuff is. But I'm getting faster over time now, probably because of programming. But I try not to copy and paste stuff, just so I can keep on getting the reps in. Okay. And we could just do address of prev target, address of current target. Sure. We could just do this to print what already exists. Oh, well, I guess that's true. We have to check first. Do we do one for each? Yeah, sure, I guess so. Oh, I accidentally did insert. Nope, I accidentally did it that time. Uh-oh. What is it? Is it just function insert? It is just function insert. Okay. Because if I do function insert, it selects the keys, but now it's off. On, off, on, off. Like that. So if, sure, and then if current target, and we're gonna dereference them to get the value that's actually there. And then we could say, sure, and I'll just say, cool. And then we can do void update targets, or yeah, I like update targets better than set targets. Standard string, a pointer to a standard string. Prev target, standard string, a pointer to it. Current target. And then pretty sure it's an L value, so we could do a const standard. I can't do address of, can I? We'll find out. What if we did well, it's gonna need to be converted to a standard string now. So we could do, can I do a string view to it? I think so. I think that's what I did earlier. Yeah, it is. But it doesn't exist. Wait, does it exist? Oh, well, okay. Well, I mean, I'll include it just in case. I'm not sure if it's since learncpp.com was made that they added string view to string or what, but I'm including it just to be explicit anyway. So I'm not later on being like, hey, why are these libraries not working? Okay. Let's do if previous target and current target, then previous target is now current target is now new target. Oops. What is wrong here? Oh wait, I have to dereference. Because this is thinking setting the address to the address. I'm not dereferencing them, which is what I need to be doing. I have to dereference everything. Oh, but can I dereference the standard string? Oh wait, actually I think that's fine. Yeah. So I can copy the value of this into here, not a pointer to it. I'll just leave it like that. Oh, oops. The issue here is updated targets. Go to update targets. To update targets, previous and or current target is invalid. Okay, so we first print the targets, and then we update targets like this. I like to do that call. That way we just have a missing the argument issue. Excuse me, not a syntax issue. And then Pass in, oops, the address of prev target, the address of current target, and then orc. That's cool. Happy with it. Okay, cool. And then current targets, we can just copy it in this case. And then cool. Dragon, goblin. Cool. Oh, hold. Oh, whoa. Oops, I didn't put a fucking else. Whoops. Okay. Like, what is happening? How could it possibly? No targets at first. And let's do 2 lines. Previous target, updated targets. Or previous target, current target, updated targets. Previous target, current target is now orc. Oh, actually, we should say. I like saying this after. We could say updating targets. Oops. Wait, what? Oh, I forgot that we're printing first. Okay. So. Oh, wait. Oops. Cool. Uh-oh, hold on. What the fuck happened? Oh, wait. We don't need to do this. I forgot that this doesn't print the targets. Previous target, current target, nothing. Updated targets. Previous target, current target is now orc. Updated targets again. Orc, goblin. Or we could say like target update. What do we say? Okay, we updated targets for the first time. We now have orc. Uh-oh, we've targeted something else. We've updated them again. Now we have a goblin, and orc was the last one. So now, if I have a thing that highlights the current target, then we can highlight this one, and whenever, and I could add other logic here that unhighlights the previous one if it's not empty. So we could say, okay, orc, there's nothing to unhighlight because it's still empty. Oh, now we're looking at goblin. The previous target is not empty. Unhighlight orc now. And then whatever. And this could just be saving the object of the actual enemy we're looking at, not the basic class, the actual enemy we're looking at right now, that instance. And then that way I look at one and it highlights it. I look over here, that one's not highlighted anymore, this one is. And that could be like a turn-based mechanic, it could be live, it could be, this could be the same for items. So update current item looking, or update, or highlight looked at item, something like that, and then I look at an item and it highlights that, and then I look at a different one. If it's a different one, it unhighlights that one. I have that stuff in my game for Unreal. Previous target or current target is now goblin. Oh, and now it's dragon, and now it's goblin. Cool. So we've had orc. Now it's goblin. Unhighlight orc. Now it's dragon, unhighlight goblin. Cool. Okay, so you can do the same thing with pointers and references. Oh, I gotta pee. Okay. So the point, passing parameters into a function, and they're out parameters. They are parameters that we are passing in order for the function to check if it's a pointer and change. But really the point is to change them. I need water. Okay. Function argument passed by non-const reference or pointer to a non-const. Sure. Let's just modify the object where it is that was passed in as an argument. Yep. So I don't like the passed by reference thing because we're passing it as an argument. We're receiving it by reference. We could just receive it by value. And we're not passing it any different way. It's just that the function's receiving it a different way. Yep. Yep. Like multiple? I mean, I could dereference the pointer to B, pass the pointer, get a return value. Well, I don't even need to pass. Oh yeah, pass the pointer to look at the value and do something, and then return it, or just pass the pointer to get updated. This is long. Let's see. Why are these double? Oh, because we're passing them to change. Okay. Okay, some double action going on. Degrees. We had a function called getSine cosine. Degrees. Okay, so we put in some number of degrees, and then we get the sine and cosine of it with fraction action and pi. Okay. get sine, cosine. We pass in degrees, sine and cosine. And now we say, hey, the sine is our sine, the double is, or the cosine is our cosine. Gotcha. And we're passing these guys by reference. Gotcha, math. The point is that we are passing these guys in as references. Changing them, and then they're actually changed. And we're not returning anything. Returns them as output. But it's not really returning. We're just updating the references. Well, it could totally matter. It's just that we're changing them, we're updating them. Because you might just be incrementing them. Output parameters are the rightmost, okay. So what I should have done before is passed in the new target, and then current target is updated to be it, and then previous target is updated to be the current target. Or that first, and then update, okay. Okay. Yep. Pass it by reference, sure. Yep. Yep. Need to remember to blink more. Yeah, and the actual ones wouldn't have changed. Yep. Yeah, unless we... No, that's it. It's the only way. Yeah. The return, this part here is maybe confusing. Return values back. I'd rather just say, like, to change objects in the caller, or to something like that. My non-const L value references can't bind to R values to temporaries. Implicit type conversion gives unexpected behavior when combined without parameters. Meaning... Is it because it fucks with the actual type of the information? With the object's type itself? If we have a non-const reference to a temporary value, we have this temporary value that exists somewhere that's of some type. It's temporary object. I'm passing a reference to it, basically a pointer to it. And if it's not const, I mean, it seems like that's the issue. We're calling, and by having it not const, some sort of conversion is happening where it's actually changing the temporary value itself, which shouldn't be changed. Because it's temporary, so maybe... Did it say it leads to undefined behavior? Oh, unexpected. Okay. There was a case on here where we pass references and they get converted. Was it just when we were talking about standard strings? Because if we had a standard string and I passed it a standard string view, I think the value of the standard string view gets copied into a temporary standard string, which is then assigned to the parameter. Because it has to be converted first. But for references, the reference has to match the type. So maybe there's a problem there with if it's const. Somehow the types aren't matching up, or they're being converted, I don't know yet. Consider this. Integer stuff. We're using uninitialized stuff. Out parameter, okay. We're doing a reference to a long. And we're passing in stuff. So it's a reference, a modifiable reference to stuff. Accepts a long reference, but is given an argument of type int. Oh, so we're saying it's only that case because of... So theoretically, it should be fine to do an int reference something and then pass in an R value. So we have an integer stuff. Maybe I ignore the fact that it's uninitialized. So we say, okay, we have int stuff. but I'm doing a reference and the reference doesn't match the type that we're actually doing. So if this gets converted via implicit conversion, if this was allowed, this isn't allowed. But if it was, then the integer would be converted to a long, which yields a temporary. There's like some hidden function over here where we pass in the int, we get a temporary long. That comes in. But now we're getting a reference to an R value temporary. Operator overloading. Hmm. Oh, well, this is just saying the behavior. Okay. How parameters have an unnatural usage syntax? What are you saying, bro? The caller must do it. Well, we're saying in this place, the caller has to create objects so that we can pass references to them. True. This is fine if we need to actually change things that must live inside the caller. Yeah, of course. Yeah, like target. Target does not need to be const. Oh, gotcha, because we have to call it first to update it, and then we have to use it after, maybe? Because the caller must pass in objects. They can't be used as temporaries. Gotcha, meaning I can't just call the function and then use them as a return value of the function. For return by value, we have an integer. Cool. Then we call get by value, and all it does is initialize x with 5. And then we output. Oh, so yeah, so we can initialize it. Or I could just output get by value. So we can get a temporary 5 and initialize it. Or we can have the temporary and just print it. But here, we have to actually update it and then use it. Yep, exactly. And instead of just calling and boom. Yeah, like saying dereference something is boom. And we pass the reference, maybe const, to see the value, and then we return the incremented value to update the pointer. That way we're not copying the pointer's value, we're not copying it back, we're just assigning it to the pointer. This is good as it makes clear that we should accept, so yeah. Excuse me. I said, yeah, okay. We're passing I, assuming these are both int parameters, or in parameters, and then maybe, or hold on, and then the out parameter, because we're passing the address. And then we have this pointer that gets the address of I, saying foo3 and pointer. Your names would have to be good. Yeah, you're saying two different ways. So we could call it and pass the address of it, thinking, oh, okay, the address might be getting changed here, or we're just passing it expensively, or passing it to avoid the expense, or we have a pointer to it and then we call it with a pointer. If I call it with a pointer, maybe this seems more like I'm passing the pointer to look at it. I might not be expecting that we're changing it. Oh yeah, because we would be Yeah, I mean, we could still add checks, and I could pass null pointer, and then it looks to make sure, hey, it's not null pointer, or it's null pointer, don't do anything. It's not null pointer, do something. So I could pass it. But if the whole point here, pretend we're not checking the pointer, and I pass a null pointer, and then it dereferences that to change it, or it says assign a value to the dereferenced pointer. Oh, you've assigned value to dereferenced null. No go. Yep, exactly. I agree. Reference seems cleaner. An in-out parameter. Yeah, like I mean, you could basically do the same thing with a static local variable almost, or get the same outcome. I mean, you pass in a number or a reference to something, and then you increment it and then pass it back. Or like you pass in, like maybe evolve Pokemon. You pass in the Pokemon's name, and then the function evolves the Pokemon. So it depends upon the value that it received, but it also changes that value so that you come out with instead of fucking Piplup, you get I don't know. There's Napoleon. It's not Napoleon. It's Emporeon. There's Piplup. I don't remember the middle one. The middle one's the shitty one. Empoleon. That's it. Aura maxed out. Let me check my eye. It feels like there's something stuck in it. Be right back. Yeah, it was a little sty. I don't think I got it, but there's a little tiny, like, mini pimple on the outside of my eyelid that rubs up against my eyeball, which is why I've been fucking with my eye so much. That makes sense? Yep, an in-out parameter. Yep, makes sense. Yeah, makes sense. Pass it in order to use the value when we're not changing it. Okay. Well, yeah, because we have to change it. Yeah, exactly. Same thing as earlier. When we're passing in a dereference pointer just to change the value at that pointer, well, we depend upon the value because we're sending it and change and looking at it first. Like, maybe it's Ark Survival Evolved. Isn't that what the game's called? And you've tamed a dinosaur, but you have to manually level it up after it's gained enough XP. So you pass in a pointer to the dinosaur object, and you have to look at the level. What level is it right now? And then you have to increment the level or whatever. Maybe you can level it up multiple times in one go. I don't know. And you level it up. Well, we're changing it, but we've also, the change that we've done depended upon the value. So not only has it become an out parameter because we're changing the value and passing it. Well, I guess we're not really passing it back. We're just, it's an out parameter because it's the output of the function, really. And it's also an in parameter because the behavior of the function depended upon, well, it's in out because the behavior depended upon the value too. Oh, now there's a hair, I think. Oh, good. Bro. Alright, whatever. I'll deal with it in 30 minutes. I think it's just the same thing. It just hurts. Right on my eyeball itself. I'll deal with it during the break. I just put hot water on it, on a thing, and then it makes the cyst just, the little pimple like come up, and then I just pop it on my eyeball. Foo, we pass in foo, and out. That way we look at it. Oh, hey, he's level 38. He's gonna go to 40 though. Boom. Now we change him to be 40. So he's an in because we've taken him in and we're looking at the value, but he's also an out. Because if it's in, we're looking at the value for sure. If it's just an in, we're looking at the value. That's what we're doing. We're printing it, or we're changing something else, or we're assigning something to be it, whatever, something like that. But it's an out because we're actually changing that object. So in this case, it's both. So if we're passing it in and we need to change it, we may as well just change it there. Right? Instead of saying foo is, or I guess we could say foo is some function called with and foo, or, well, in this case, we're just calling foo with a reference, so it makes sense. I'm thinking in pointer talk. I don't like after. I like during. Foo is modified during this call. In this call. Modify foo, we call that. That's why I said set targets or update targets. It's not, oh, get targets. Get targets? What you talking about, bro? It doesn't return anything. Slightly. It's a lot more obvious. Yeah, exactly. And do we want to do that? But maybe it's expensive. Yeah, exactly. Yeah. In this case, we have foo. We pass it with foo, and we say foo is something with this. So we have, hey, foo. Foo. There's a parameter here. So we're making a copy of it. This guy. So I guess there are two. Saying, hey, passing in foo. The value of foo is copied to make this guy. But then the return value is copied to then go back to foo. So we're passing in, and I don't like this shit here. Like, so what? This is the whole point here is we're saying, hey, there's some variable that we're creating of type foo, and we're copying the input into it, and then we're returning it. So it seems like this is copied. This is copied to a temporary, but then this is copied to create this guy. Oh, wait, hold on. Oh, in this case, we're saying foo is, we're actually passing a reference to it. Okay, whoops, I totally missed that. So we have a reference, so there's no copy for initializing the parameter. We are copying the value of it here, though. And we're also returning it, which returns a temporary. Well, and the temporary is really here. Temporary from this guy. And then yeah, using the value by copying it instead of modifying it directly. Because this is a const reference. or use passed by non-const reference when a function would otherwise. Hold on. Yeah, do it when it's cheap, yo. So instead of initializing this guy with an expensive ass version of this that we've copied, instead we just change it. So instead of saying foo is generate expensive foo foo, we just call this to avoid this copy here. The temporary return value. Like, for example, objects that we're looking at, and we need to update them, or we need to update the ones that I've currently saved copies of. I want to update those where they are in memory and not copy a whole another object and copy a whole another object back. Oh, fuck that. And actually, I would have to manipulate them because I'm referencing that object itself. I have to unhighlight it. Oh, okay, because we pass an array and then fill it with information. Yeah. And the array has an expensive to copy element type. Gotcha. So like an array of objects, or well, an array of expensive objects. Gotcha. Rarely, really. Okay. Type deduction, huh? Auto. So what? Could we do something like? Oh. Yeah, it's a pointer to an int. Okay. Oh yeah, and true in reference. So how about? Should I say const auto? Or does auto already say, hey, it's already a constant? Oh. So it does find const. Okay. How about for references? A reference of an auto type. Okay. I thought I heard it. I thought I read a qualifier that said, "Hey, P.S. This doesn't happen for pointers." Because otherwise, if we did auto for a pointer to look at a constant, then we could actually change that in via the pointer, even though it's const. Really? Yeah, it doesn't pull it. Const is dropped. What if I did hi, Matt? Can I have a variable that stores it all? Oh shit! Pointer to a const character, huh? Alright. Now what if we do X for X auto. Yeah, it 100% does drop it for regular variable type deduction. A const auto, yeah. $7.8, and then we could say, hey, take 7.8 and make a const double out of it. Hey, take a const double 7.8 and have a const auto as well, or a const double, whatever. Now we're doing a const. Gotta make them const D, because auto will drop it, so we keep them const. And then same thing, auto E with C, const expression. So it's a const expression auto. So yeah, at compile time, type deduction occurs. Type deduction will drop references? What are you talking about? So if we get a reference to something. Because it's just looking at the object, not the alias. So an auto reference guy, huh? Oh, an auto. Gotcha. That's what I did earlier. An auto reference. Oh, and I guess you would have. So the point here is this wouldn't be for a local variable because. Right, we can't. The lifetime can't be prolonged unless it's static. Say it is static, or say it's a global variable somewhere, like the player character in Unreal Engine, and I'm returning a reference to the player character so we can look at it. Well, in this case, it's just going to create another object that doesn't look at the player character. It's not an alias of it, which is what it should be. Instead, it creates another one. No, sir. Instead, we could say hold. Oh yeah, this needs to be const because otherwise we could technically change it. Okay. And the type of X, not a reference. So we need to do an auto reference. Boom. And if I just did standard string reference, no sir. Because now we have a reference to it, but it's not const. Not allowed. If something's const, all references to it must also be const. Yep, dropped and then not dropped. Yep. Oh, well, I guess that's the case, huh? Auto says, hey, it's a standard string, but it's a reference to a standard string. We have to reapply it. A top level const is a const qualifier that applies to an object itself. What in the fuck? What are you saying? Are we talking about like, treating it as const when it's not? What are we saying here? Constant x applies to x, top level. Versus the const pointer. Oh, gotcha. Yeah, it applies to the pointer. Okay, yeah, because you could only do the const something reference, yeah. Yeah, it applies to the object, not the reference, because a reference isn't an object. The low level. Gotcha. The pointer being const versus the reference being const. The references are already. Oh, gotcha. Because yeah, because references are already the reference. So this is the variable itself. This is versus having. So if we had this, but then I had a const, a pointer to const, that's low level because we're looking at the thing. So if we say at the high level we have the pointer that's looking at something. That's high level. We're saying you are const. Doesn't matter what this guy really is. You are const. You can't be reseated, Mr. Pointer. Boom. You can't be changed, variable. Wait, hold on. Yeah, some object itself versus low level is when there's something else that's looking at it. Really? So it seems like it's the reverse, actually. A top level const is a const qualifier that applies to an object itself. A low level applies to the object being referenced or pointed to, meaning that if the object itself is something that can refer to other things, as in a pointer or a reference, and we're talking about the reference, a const type reference is a reference to a const thing. A pointer to a const thing is a const something pointer, not a const something const pointer. And a reference to a const value is that because references describe the object that's being looked at always. Gotcha, or both, because it's the pointer itself is const and the object it's looking at is const, the low level and the high level. And an object that can't refer to another object, like x, it only has the value of other stuff, refers to itself, versus the pointer that's storing an address of something else can refer to itself and something else. So a reference can only be low level because it's what it's referring to. Gotcha. Versus a pointer can be const itself, high level, or refer to a const, low level, or be both, const pointer to a constant. Versus the variable can only be const itself. There's nothing that it refers to, so it can only be top level. Yeah, the left const is low level because it's referring to the object being pointed to. The right is top level because it's referring to the object itself, the pointer. When we say it only drops to top level, so oh, I think I found this earlier with pointers. Const int x5 auto an auto pointer of xp initialized with the address of x keeps const because it keeps the low level type, the type of the object. It's just that it doesn't. If I had an auto, oh, it made it const xp. It's a const pointer, so it's pointer to, well, const pointer to const versus an auto pointer xpp, a pointer to the a pointer to x's pointer, and we just initialize it with xp. In this case, it's not a const pointer, it's just a pointer to a constant. So type deduction drops the top level const, which is why we can't have, which is why we have an auto. References are only low level, so there's no const reference. It's just a reference to a const. So if we get something, if we have an auto something and pass it a reference, it's still at least a const whatever. Like, it's still a reference to a const. Type deduction and const references. A const reference to something and type deduction. Seems like we don't drop anything for references then. It's just that we lose the reference part. So it thinks that it's just a const something. Let's see. The initializer is a reference to const. Hold. So if it's a reference to a const pointer, then it'll be to a const. It'll say that, hey, this is a pointer to const. So we could say, hey, here's a wait, hold on. That's a function, get const reference. It returns a const standard string reference, and we have auto to get that. We lose the reference. It's a const standard string, so we don't lose that const. Oh wait, hold on. It is. Really? Oh, because if we drop, hold on. Oh, because if we drop the reference, then that's just a const that describes the standard string. So this is just a standard string ref1. Yeah. This shit is getting weird. I hate type deduction so far. Maybe it's helpful in some way though, I don't know. So type deduction drops top level consts and it also drops references. Both. So it's not a reference to something, it's that something, or it's the type of that something. But if that something has top level const, it drops it. So if it's a reference to a const pointer to a const value, we drop the reference, so now this is just a pointer to something. But instead of it being a const pointer to a const value, it's just a pointer still to a const value because that's the low level that we don't drop. Because the pointer refers to something else, so its own const is top level. The const of the thing it's referring to is low level. We don't drop the low level. Returns a standard string, we drop the reference, and we also drop the const because standard strings don't refer to anything else. Dropping a reference may... Wait, hold on. const standard string reference is a low level const because it refers to the thing that the reference is referring to. It's const. The reference's referent is const, so it's low level. Oh well, yeah, that's true. Yeah, because const standard string. Well, and okay. Well, yeah. So this by default, as a reference, means that we have an object, or well, we have a reference to a something that's const. So if we do type deduction with it, if this is a pointer to it, we don't drop anything. We only drop the pointer's const if the pointer was const, but it's not. In this case, we have a reference. We're dropping the reference. We get the object because whenever we look at a reference, we're looking at the object. We don't give a fuck about the reference. It's not an object. We look at the object it's looking at. Which is a const standard string, which itself is high level. Something that's looking at the const standard string, it's low level. Right here, it's low level. But when we drop the reference, it becomes high level. Excuse me, or top level. Low, high, low, top. Should be low, high, honestly, but whatever. Dropping the reference yields const standard string, which is the top level const, which is why we can drop it. So we would say, we'd have to say a const auto ref1 or const auto reference ref1. Yeah. Because we're dropping the reference and we want this to still be a reference to an existing object. We don't want this to just get the value of the object. Because otherwise this is a separate object. And we'd have to copy it over instead of just, oh my god, just looking at it. All right, 30 minutes. Oh yeah, I gotta heat my food from yesterday. I made some really good pasta. It's purple. Cool. No. Well, whatever. It's fine. All right. I'm out for 30 minutes.